Very good morning to you, student. Today I'm going to discuss you some problems on divergence. So far I have explained to you what is meant by divergence and a curl of a vector function. So what is, I'll just recall the definition of divergence here. Divergence of a vector, if you have a vector fill function v bar, what is the divergence of v bar? It is del dot, this dot stands for the scalar product of this operator del with the scalar vector function v bar, and by operator del we have it is equal to I del del x plus j del del y plus k del del z dot v bar, which is nothing but I dot del v bar del x plus j dot del v bar del y plus k dot del v bar del z. So this shows that a divergence of f is a scalar function. Divergence here is a scalar function or a scalar quantity. Okay, so I hope it is clear to you what is meant by divergence. So using this definition, just like in the case of gradient, whereas in gradient you have gradient you have here it is del v, where v here is a scalar function, whereas in a vector, in a divergence, v bar is a vector function. So we define scalar of f as del dot v bar. So if you have these problems, f bar is a vector point function which is x square set I minus twice y square set square j plus x y square set k cap, then find divergence of f. So here solution, divergence of f bar here is equal to del dot f bar, which is equal to I del del x the operator plus j dot del y plus k dot there is no dot here, k del set dot of vector f bar. According to definition of divergence, we have this relation, this formula. So you replace f here. So you have I into I, according to definition, it is I dot. So I dot del f bar del I dot del f bar del x plus j dot del f bar del y plus k dot del f bar del z. But what is f bar? F bar is this x square I. So you replace it by that. So you have I dot into del x of this whole function, that is x square set I minus twice y square set square into j plus x y set square set into k cap plus j dot del y of again this one x square set minus twice y square set square into j plus xy square set into k cap, and then plus k dot of this. So k dot del set of again this function f bar, that is x square set, there is I no here, so there should be I. So x square set I minus twice y square set square into j plus xy square set into k cap. Now del x here is the partial derivatives of x with respect to this function f with respect to x. So treating set as constant, what you have here, it is I into twice x set into I dot here, there is dot here. So and then plus here there is no term containing x, so partial derivatives of this will give you 0, but here you have x here, so it will give you differentiation of x with respect to x gives you 1, so it will remain as y square set into k cap, and then plus j dot, here you have I, okay. So j dot del y of this, there is no term containing y here, you'll get minus 4y set square into j, and then plus 2xy set into k, and then plus k dot del set of this, you'll get x square I, and here again there is set, so you have minus 2 into 2 gives you 4y square z into j, and again here there is z, so you'll get plus xy square into k. Now apply the scalar dot function. I dot I gives you 1, so what remains here, it is twice xz. Now I dot k, it is equal to 0, so you have 0, and then plus j dot j here gives you 1, so you remain as minus 4yz. 4yz square, I think, yeah, there is z square, and then plus j dot k gives you 0. So you have here k dot I gives you 0, k dot j 0, but k dot k gives you 1, so you have xy square. So this is divergence of vector f bar, which is equal to twice xz plus minus 4yz square plus xy square. Now del dot f bar at the point, what is the point here according to question? It is 1 0 minus 1, so 1 0 minus 1, it is equal to, you replace x by 1 and z by minus 1, so you'll get minus 2 here, and then if you replace y here by 0, so this whole term becomes 0, but here you have x against 0, so what do we have here? It is equal to minus 2, because there is y here, no? So 0 0, because since the value of y is called 0, so it will be minus 2. So this gives you the value of the gradient, the divergence of a vector f bar at the point 1 0 minus 1 is equal to minus 2. I hope it is clear to you. Now let me recall again the definition of this curl of a vector, or I'll explain in the another video for the curl of a vector function.